Have you ever looked at an average and just had a gut feeling that something's off, that it doesn't quite capture the reality of the situation? Well, trust that feeling. Today, we're going to pull back the curtain on stats and show you what's hiding behind that single number. We're going to turn you into a proper data detective.
All right, let's kick things off with a little puzzle. Imagine you're an investor and you're looking at 3 different firms. The report lands on your desk, and it says they all average £5,000 a day in sales. On paper, they look like triplets. But just based on that one number, can you really tell which company is the most stable, which one is the safe bet?
And here's the raw data. Now look at this. Firm A is just rock solid. $5,000 every single day. Firm B, it wobbles a little, but it stays pretty close to the mark. But Firm C, whoa, it is a total roller coaster. Some really bad days, and then one absolutely massive day that pulls the whole average up. And yet, when you do the math, they all have the exact same average. This right here is the problem. The average is lying to us.
So that one number, the average, it gives you a sense of the center, but it tells you absolutely nothing about the spread, the risk, or the reliability of the data. It completely papers over that chaos we just saw with Firm C. And if you're trying to make a smart decision, that's a huge blind spot. We need better tools.
So let's open up our Data Detectives Toolkit. The first and simplest tool we can grab is called the range. And it's exactly what it sounds like. You just find the highest number and the lowest number in your data and find the difference. That's it. It's our first step towards seeing the whole story.
Now let's apply this to our 3 firms, and wow, the picture gets clear fast. Firm A has a range of 0. No surprises there. Firm B has a pretty small range, just over £300. But Firm C, a massive range of £11,200. All of a sudden, these 3 identical companies look very, very different, don't they?
But the range isn't the perfect tool. I mean, its biggest pro is that it's super simple. Anyone can do it in like 2 seconds. But that's also its biggest weakness. The source material calls it a crude measure, and for good reason. It only looks at 2 numbers, the absolute top and the absolute bottom. It completely ignores the story of all the other numbers in between.
So yeah, the range gave us a hint, but it's easily thrown off by one weird day. It's a bit of a blunt instrument. To really get what's going on, to truly understand the consistency and risk, we need something more powerful. We need a tool that actually looks at every single data point.
And that, my friends, brings us to the gold standard. This is the tool that data scientists, researchers, and yes, savvy investors use every single day to get past the noise and see what's really happening. It's called standard deviation.
So what is it really? Well, put simply, standard deviation tells you the typical distance that any one value is from the average. Think of it like this. A small standard deviation means all your numbers are huddled together, nice and tight, around the average. A large one means they're scattered all over the place. It's a measure of consistency.
Now, the formula can look a little intimidating, but the idea behind it is actually pretty straightforward. First, you get the average. Then, you measure how far every single data point is from that average. Now, since some distances will be positive and some negative, you square them all to make them positive. You take a special kind of average of those squared numbers, that's called the variance, and finally you just take the square root of that to get back to your original units, like pounds or dollars. And that's it. That's your standard deviation.
And just look at the payoff. When we run the numbers, the standard deviation for Firm A is 0. Perfect consistency. For Firm B, it's a nice small number, telling us it's very stable. And for Firm C, it's a huge number, giving us a concrete value for the chaos we saw in the data. The puzzle is solved. We now have one powerful number that truly describes the stability of each company.
Okay, so that's great for comparing similar things. But what happens when you need to compare 2 totally different things? We've got an apples and oranges problem. For instance, how do you compare the sales consistency of a huge market versus a tiny one? A 10,000-pound spread might be nothing for a big region, but it would be a disaster for a small one.
Let's make this real. Look at this. We have one sales region averaging 86,000 pounds with a standard deviation of about 10,000. Then we have another, smaller region averaging 45,000 with a smaller standard deviation of 6,000.
So which one is more consistent relative to its size? It's not as simple as just picking the smaller number.
To solve this, we need a more advanced tool from our kit. It's called the coefficient of variation, or CV for short. And you can think of it as the great equalizer. It creates a level playing field by showing the standard deviation as a percentage of the average. This lets us compare the relative consistency of different datasets, no matter how big or small their numbers are.
So what does the CV tell us about our two regions? Well, for the big region, the CV comes out to about 12%. For the smaller region, even though its standard deviation was lower, its CV is actually a bit higher, around 13%. So, surprise, the larger region is actually the more consistent performer. The takeaway is simple. A lower CV always means more consistency.
Okay, we've figured out how to find the center of our data and how to measure its spread. But there's one last piece of the puzzle. To really understand the story, we need to look at its shape. Is the data all balanced and symmetrical, or does it kind of lean to one side? We're about to uncover the personality of our data.
And this idea has a name. It's called skewness. The source material puts it perfectly. It's just the lack of symmetry in a distribution. In the real world, you almost never find data that's perfectly balanced. Most of the time, it's got a bit of a lean to it. We call that lean a tail.
And there are three main shapes this can take. First, you have a perfect symmetrical distribution, where everything lines up nicely. Then you have a positive skew. This is where a few really high values, like that 13,000 pound sale from firm C, drag the average up and pull the long tail of the graph out to the right. And then you have negative skew, which is the opposite, where a few unusually low values drag the average down, pulling the tail to the left.
Now, reading the skew can feel a little backwards at first. So this quote from our source text is super helpful. It says that a negative skew, where the tail points to the low numbers on the left, actually means that the bulk of your data is piled up at the high end. It's the few low numbers that are the outliers.
Let's look at a real example. A study of company profits came up with a skewness of negative 0.5310. Just from that one number, we immediately know two things. One, the data is negatively skewed, and two, that tells us a powerful story. The vast majority of companies in that dataset were actually clustered together at the higher end of the profit scale.
So there you have it, the complete data detective toolkit. You can now look past a simple average. You can measure the spread to understand the real risk and consistency. And you can analyze the shape to see where the values are truly concentrated. So the next time you see a statistic, don't just nod along. Ask yourself, what story is this data really trying to tell me?